Hello, welcome to this film which is about solutions. It's just an introduction to the topic, and hopefully by the end of it you'll know what happens to a solute as it dissolves in a solvent, or a solid dissolving in a liquid likewise, and you'll know the meanings of some really important key terms that we use when we're describing solutions. Okay, so just an intro to the topic, but really some quite important information here that you need to be familiar with. Okay. What is a solution, first of all? Okay, well, a solution is formed when a solute dissolves in a solvent. In this particular example that we can see a diagram of, here's our solute, so it's some ionic solid, we can see the charges on it, and it's actually dissolved in water. So the solvent is water, and the solute is the solid that's dissolving in the water. So this is actually what's called an aqueous solution because the solvent is water. Water's not the only solvent. There's lots and lots of other liquids that we can use as solvents, and they just don't make aqueous solutions. Now, in general terms, as a kind of rule of thumb, but it's not always true, the solute will be the solid and the solvent will be the liquid. However, you can have solutions that are made up of two liquids, for example, and in those cases the solvent is just the one that dominates, so it's the one that there's more of. So if I had a little bit of water and I mixed it with lots of ethanol, that would be a solution of water in ethanol, and the ethanol would be the solvent and the water would be the solute. Okay, but in general, as a rule, which doesn't always work but works most of the time, the solid is the solute and the liquid is the solvent. Okay, what does solubility mean? Well, solubility is a measure of how much of a substance will dissolve in a certain amount of solvent, and when you reach that substance's solubility, you've made what is called a saturated solution. That's a solution that can't hold any more of that solute, so if you try and dissolve more of it in that amount of solvent, you will fail. It just stops dissolving. Although when we say it stops dissolving, it's not to say it has the dissolving process has stopped altogether. It's just that, as shown by these arrows here, the solid is dissolving at the same rate as the dissolved solid is undissolving or becoming solid again. Okay, and when something becomes solid again or comes out of solution, we're talking about crystallizing. All right, so if I had a solution that was saturated and I started to evaporate some of the solvent, I'd be left with some of the solute behind. It would come out of solution, it would crystallize, even though that solid often doesn't look particularly like crystals. Okay, and just finally here, what does this word dissolving actually mean? Well, dissolving is termed, or it can be explained as being the spreading or the homogeneous spreading of a solute through a solvent. Okay, so there's some key terms. Watch that slide again if you want to just be sure of those, because they really are quite important. Now, moving on to things that affect solubility. So what sort of things will affect how much of a substance will dissolve in a solvent? Well, primarily this is temperature, but we've just got to be a little bit careful because it's different for solids to gases. Okay, we can dissolve solids in liquids, we know that, when sugar dissolves in water or salt dissolves in water, and generally if you raise the temperature, the solubility of the solid will increase. So I can dissolve more of a solid in a solvent if the solvent is hotter. However, it's the opposite for gases. Okay, often people struggle to think of examples of gases dissolved in liquids, but any fizzy drink has carbon dioxide dissolved in water. Okay, and gases actually fall, their solubility falls as the temperature rises, which explains why fizzy drinks go flat a lot quicker when they're warm. Okay, what does solubility actually mean? Well, this can be a little bit confusing because even substances that we don't think dissolve actually do dissolve to a tiny extent. They might not look like they're dissolving very much, but a few particles will always dissolve. Okay, so when we say something's soluble or insoluble, we're talking about shades of grey. We're not talking about black or white. Okay, and the waste definitions, where 0.1, this is all measured in moles of solute per litre of solvent. So anything over 0.1 of a mole per litre is termed soluble, and most ionic solids will dissolve at least that much. Okay, anything between 0.01 and 0.1 of a mole in every litre is called slightly soluble, and anything that is up to 0.01 of a mole in every litre is termed insoluble. Okay, so a substance that, let's say, I could only dissolve 0.005 moles in every litre of solvent, okay, it's clearly dissolving a little bit, but by these definitions we term it insoluble. Okay, now we're moving on to some more very important key terms. Electrolytes are substances that will dissolve in a solvent and conduct electricity because of the fact that they release ions into the solution. Strong electrolytes are ones that will break up entirely into ions. Okay, and the way to know if something is a strong electrolyte is quite simply, is it ionic? Because if it is, then it's a strong electrolyte. And is it a strong acid? You should know what the strong acids are by now. Okay, they're hydrochloric, nitric and sulfuric, and some others which you don't really need to remember. But if it's a strong acid or it's ionic, you know it's going to be a strong electrolyte. If it's not one of those two things, but it's a weak acid or a weak base, now in year 11 it's good enough just to remember that there's a weak acid and there's a weak base, so there are weak electrolytes. In year 12 you actually come across a few more weak acids and a few more weak bases, but any weak acid or weak base will be a weak electrolyte. And if your substance, I don't know, let's say sugar, for example, which isn't ionic, isn't a strong acid, and isn't a weak acid or a weak base, then it's termed a non-electrolyte. Okay, so this will release no ions in solution. These substances, some of their molecules will split up into ions, but not very many, whereas strong electrolytes will split up entirely into ions. Now, just to finish up with, let's just kind of check our understanding of some of these key terms. Okay, why electrolytes? Well, electrolytes are substances that will conduct electricity. Why do they conduct electricity? It's because they release ions into solution when they dissolve. Okay, now people often get confused a little bit between solubility and electrolyte strength, because if something's a strong electrolyte, that makes it sound like it's going to dissolve very well. However, if you look at a substance like silver chloride, which is clearly ionic because it's got a metal and a non-metal, that has a very low solubility. In fact, it's termed insoluble, but it's a strong electrolyte. And what this means is less than 0.01 of a mole of silver chloride will dissolve in every litre of solvent, but any of it that does dissolve will all split into ions. Okay, if you compare that to a weak electrolyte, like let's say ethanoic acid, okay, dissolves extremely well in water. It's got a very high solubility, but hardly any of it turns into ions when it does dissolve. Okay, so that's about it for that short introduction into solutions and dissolving. Hopefully everything in that film is clear. If not, come and get some help with it. And if you're ready to move on, the next film to watch is the film about concentration and what we mean by that term, how it relates to solutions.